Hello everyone, welcome to my poster. In this work, I have examined whether numerical magnitude affects our temporal experience or simply bias our temporal judgment. Let's start. Investigation of the space-time and number have always been fascinating for philosophers and neuroscientists. Unlike physicists, neuroscientists and philosophers are interested in subjective time, which is also known as time perception. Previous studies have shown that our perception of time is influenced by the various factors such as emotion, color, etc. In addition to these factors, more recent studies have shown that temporal perception is also influenced by task-irrelevant, non-temporal stimulus properties such as number and size magnitude. For example, it has been observe that large numerical magnitude is judged to last longer than a small numerical magnitude. Such cross-domain magnitude interaction has explained by a theory of magnitude. This theory is also known as the atom framework. According to atom framework, space, time, and number are processed through a common magnitude system in the brain. Therefore, the task irrelevant magnitude would potentially interact with the processing of the task relevant magnitude dimension. Many behavior and neuroimaging studies have found support in favor of atom and supported the idea of a common magnitude processing system. However, it is not clear whether such cross-domain magnitude processing arises from the change in the accuracy of the magnitude judgments or result from the change in the precision of the magnitude processing. Therefore, in the present study, we examine whether the numerical magnitude affects temporal accuracy or temporal precision or both. In other terms, we investigated whether numerical magnitude changes our temporal experience or simply bias our temporal judgments. To investigate the numerical magnitude processing and its influence on temporal experience or temporal bias, we used a temporal discrimination task. 24 participants recruited from IIIT Hyderabad and asked to perform a duration discrimination task for the two sequentially presented numerical magnitudes. The first magnitude was always a 5 and had a fixed duration of 550 milliseconds. And the second magnitude was either 1, 5, or 9, presented with varying duration from 250 millisecond to 850 millisecond in the steps of 100 millisecond. Please see figure 1. Participants were asked to judge whether the duration of the second magnitude was longer or shorter than the first magnitude. Participants were also informed that numerical magnitude was task irrelevant dimension. After the experiment, we estimated temporal accuracy in terms of PSE and temporal precision as Weber ratio for each numerical magnitude. PSE is the point of subject equality, which was defined as a point on a psychometric curve at which 50% of the time participants perceive the duration to be longer and 50% of the time participants perceive the duration to be shorter. If the PSE is lower than the standard duration, in this case 550 milliseconds, we call it overestimation of time. And if the PSE value is higher than the standard duration, we call it the underestimation of time. After calculating the PSE, we used a one-way repeated measure ANOVA to estimate whether The PSE across the three magnitude, three numerical magnitude were observed different or not. We have shown that the large numerical magnitude, that is 9, is perceived to last longer than the small and the identical numerical magnitude. However, such overestimation and underestimation of duration is relative in nature. This means that the temporal overestimation and underestimation were observed with respect to the numerical magnitude. However, we do not observe statistical differences with respect to the standard duration. Please see figure 2 in the results section. Further, to investigate whether the numerical magnitude affected our duration discriminability, we computed the Weber ratio, which is the index of sensitivity. We found no influence of numerical magnitude on the Weber ratio, suggesting that the numerical magnitude did not affect the duration discriminability. Please see figure 3 in result section. Given these results, our findings suggest that temporal accuracy is biased by the presence of numerical magnitude, but did not modulate temporal precision. We suggest that such biases can occur from the attentional mechanism and may not contingent on the existence of a common magnitude processing system proposed by the atom. Thank you.